Okay, so in this problem, I'm given a right angle triangle, and I'm given the sides of that right angle triangle in terms of x. So I have the two legs have lengths 2x plus 6, x plus 2, and the hypotenuse has a length of 3x plus 4. And we are asked to find the length of the hypotenuse, find the length AB. All right, so what we're going to do is we're going to use Pythagoras' theorem to set up an equation with these three sides. So Pythagoras' theorem tells me the square of this side plus the square of this side equals the square of my hypotenuse. That's Pythagoras. So let me write that down mathematically. That means then that I have that 3x plus 4 squared, it's my hypotenuse squared, is equal to 2x plus 6 squared plus x plus 2 squared. And so it remains for me now to just solve this equation. All right, so let's square out our parentheses here. 3x plus 4 squared. I square the first term. That will give me 9x squared. I will take the product of the two terms and then double it. So 4 times 3x is 12x, times 2 is 24x. And then square the last term, it's plus 16. Is equal to, I'm going to do the same thing here, square the first term, that's 4x squared. Product is 12x, double that is 24x, plus 36. 6 squared is 36, plus x squared, 2 times x is 2x, double that is 4x, and then 2 squared is 4. Okay, I'm going to bring everything to one side. I'll bring everything to the left-hand side. So that will give me 9x squared plus 24x plus 16. Subtracting everything to the left, that gives me minus 4x squared minus 24x minus 36 minus x squared minus 4x, almost there, minus 4 is equal to 0. All right, I think that's everything. And now I just have to gather up my like terms. I have 9x, I have an x squared term, an x squared term, and an x squared term. So 9x squared minus 4x squared is 5x squared minus x squared, that's 4x squared. I have a couple of x terms. 24x minus 24x is 0. Minus 4x is, well, 0 minus 4x is minus 4x. And then finally, I have 16 minus 36. 16 minus 36 is negative 20. Negative minus 4, so that's negative 24 is equal to 0. Okay, so I end up, when everything is gathered together, I end up with a quadratic trinomial, and I'm now going to solve this quadratic trinomial. To make things a little easier for myself, I can divide across by 4. So I can eliminate my 4 here, so I get x squared minus x minus 24 divided by 4 is 6 is equal to 0. And I will solve my quadratic trinomial. I'll try trial and error first, see if I can do that works. So I have an x squared here, so that's x and x. I want factors of negative 6. It will sum to negative 1x, so that will be minus 3 plus 2. Minus 3x plus 2x, that is gives me minus x. And of course that's equal to 0. So in order to solve this then, we have that the quantity x minus 3 times the quantity x plus 2 is equal to 0. It follows then that either x minus 3 is equal to 0 or x plus 2 is equal to 0. Solving this, I get that x is equal to 3. That is one of my solutions. Solving this, I get x equals negative 2. That is another solution to that quadratic trinomial. We are asked ultimately to find the length of AB. So the length of AB is 3x plus 4. So AB then is 3x plus 4. If I try x equals 3, that gives me 3 times 3 plus 4. 3 times 3 is 9, plus 4 is 13, and so I get a length of 13. If I was to try x equals negative 2, I would get 3 times negative 2 plus 4. This is negative 6 plus 4 is negative 2. That is a solution that I can ignore. I'm getting a length of AB, which is negative. That's a non-physical answer. And so I will discard the answer x equals negative 2. And so the length of x, the solution for x that I will choose is x equals 3. That gives me a length of AB equals 13. Gives me a length of AB equal to 13. Just to fill it out, it also gives me a length of BC, which is 3 plus 2. This is 5. And this would be 2 times 3, that's 6 plus 6. This is 12. And so what I actually have is the famous 5, 12, 13 right-angled triangle. 5 squared is 25, 12 squared is 144, 25 plus 144 is 169, 13 squared is 169. Okay, so that is that problem